do is the derivative of polynomial functions. So this is going to be a quick lesson, but it's going to have a lot of material and you need a lot of practice. So there's going to be a lot of rules that I'm going to throw at you right now. Okay, if we have a function that's just a constant, then the derivative is just 0. Okay, in Leibniz notation, it's d by dx of k equals 0. So what's the derivative of f prime at x equals, well, f prime at 5 is just going to be equal 0 because 5 is a constant. Okay, when we get y, we have to use dy by dx of a constant. Again, it's just 0. Okay, don't let pi fool you. Pi is just the number 3.14. Now the power rule. From 2.1, we did the long derivative of x squared, x cubed, and x to the 4. Now we're going to use a quick way of doing it. So what we do is we basically take this n, we bring it to the front of x, so we have xn, and then we subtract 1 from the exponent. Okay, so bring the 7 down, so f prime at x equals 7x, and then subtract 1 from the exponent, 7x to the 6. It's done. That's the derivative. Okay, I'm going to actually rewrite this. Instead of 1 over x cubed, I'm going to use x to the negative 3. Now I'm going to bring down the negative 3, x, and then I'm going to subtract 1, so negative 4. Okay, when we use the letter s, we have to write ds by dt, okay, because this is time. Okay, bring the 3 over 2 down, so 3 over 2t, and then what's 3 over 2 minus 1? 1/2. Done. Okay, d by dx of x. So this is x to the 1. So dy by dx equals, bring the 1 down, which is just 1, and x to the 1 minus 1 is x to the 0. Well, we can just say 1. So the derivative of any variable x is just 1. Okay, the next rule is the constant multiple rule. So basically, if we have a constant multiple in front of the equation, you can pull it out and just take the derivative of the equation. Okay, so we have f prime at x equals, so from 7x to the 3, we're going to just write the 7, but now we bring down the 3, and then we subtract 1 from the exponent. So this one's 21x squared. Okay, f prime at x equals, just leave the 12 as it is. All we're going to do is differentiate this x to the 4 over 5. So we're going to bring down the 4 over 5, x, and then what's 4 over 5 minus 1? I get negative 1/5. Okay, in other words, this is 48 over 5. And then x to the 1/5 can be on the bottom because it has a negative exponent. Okay, the sum rule and the difference rule, very similar. Sum rule is if we have two equations that are added, we just add the derivatives of both equations. Okay, that's it. Difference rule, if we have two equations that are subtracted, we just subtract in order the derivatives of each equation. Okay, so let's try A. So we have f prime at x equals, okay, bring that down, 3, 3, 6x, 2 minus 1 is just 1. Okay, minus, we have a 5 here. Instead of dealing with 5x root x, let's deal with 5x to the 1/2. So we bring this 1/2 down. We write x, and then 1/2 minus 1 is negative 1/2. Okay, I get 5 over 2. And then instead of writing x to the negative 1/2, I'm just going to write it x to the 1/2 in the bottom. Okay, and that's it. Y, we use dy by dx. Okay, bring this 2 in front. Write the, oh, you know what? I'm going to teach you chain rule after. What I'm actually going to do is I'm going to expand this. 3x plus 2. Okay, so we have 9x squared plus 12x plus 4. Okay, in this case, 2 times the 9 comes in front, times 2x to the 1, plus when we derive just a variable x, it just becomes a 1, so it's just 12 times 1. And then when we derive a constant, it becomes 0. Okay, so we have 18x plus 12. All right, last example, example 5. Determine the equation of the tangent to this graph at x equals 1. Okay, so first let's actually find f at 1. I get -1 plus 3 minus 2. That's 2 minus 2, 0. I get the point 1 comma 0. Okay, now f prime at x equals, bring this 3 down, we get -3x squared because we're subtracting 1 off of there. Okay, bring this 2 down, so 2 times 3 is 6, x, and then 2 minus 1 is just 1. And then constant just goes to 0. Okay, f prime at 1, so we want the slope at the point 1. So we just sub in that 1 to the general form. And again, these are general forms of the equation or of the slope. I get 3. Okay, so y equals mx plus b. I get the slope of 3, and then we have the point 1 comma 0 plus b. Bring that 3 over. -3 equals b. I get the equation y equals 3x minus 3. Okay, here's the second thing. Determine on the graph where the tangents are horizontal. Okay, this is x cubed. So we have potentially, and it's negative, so it's going from this quadrant to this quadrant, and it potentially has 2 points where the tangents are horizontal. When we're looking at horizontal tangents, we're looking for this slope of -3x squared plus 6x to actually equal 0. So let's just factor this. -3x, when does this slope equal 0? -3x, we can get x minus 2. This slope equals 0 when x equals 0 and x equals 2. Okay, it wants the points. These are not points. These are only the x coordinates. So we sub these into the original and we get 0, comma, -2. And we get 2, comma, okay, this is -8 plus 2 and 2 is 4. 4 times 3 is 12 minus 2. I get -2. So those two are the points where the tangents are horizontal.